Hello again, welcome to Cardinal Science. Today we'll be working through specification points 1.8 and 1.9 of the Edexcel IGCSE Chemistry 27 specification. By the end of this video, you should be able to confidently tick off these 2 points on your revision checklist. Specification point 1.8. Understand how to classify a substance as an element, compound, or mixture. And 1.9. Understand that a pure substance has a fixed melting and boiling point, but that a mixture might boil over a range of temperatures. Specification point 1.8. Understand how to classify a substance as an element, compound, or mixture. So, you're going to have to be able to state whether a substance is an element, a compound, or a mixture, and to do that, you're going to have to know what they are. An element is a substance that contains only one type of atom. It cannot be split into anything simpler. Think of a pure gold bar, for example. Every single atom in that bar is a gold atom, nothing else. It's gold all the way through. That's what an element is. If you look at the diagram, the colours indicate specific elements. So in both the solid case in blue and in the gaseous case in green, the structures are made up of only blue or green atoms. They're both elements. Now, a compound is a substance that is made up of 2 or more elements chemically combined. The chemically combined part is very important. The elements cannot just be physically mixed, for example, some lumps of gold dropped in a beaker of water, but they must have undergone a chemical reaction and formed new chemical bonds. If you look at the diagram, you can see that the different coloured atoms now form part of the structure and of the substance in both the solid and the gaseous cases. Now, we briefly touched already on what a mixture is, but I'll clarify it again. A mixture is a combination of 2 or more substances that are not chemically combined, i.e., they are just mixed up. They're physically associated. The atoms are not chemically bonded. They're just near each other. The best examples of this is the atmosphere. It is made up of nitrogen, carbon dioxide, oxygen, and many other gases. Some of these gases are elements like oxygen and hydrogen, and some are compounds like carbon dioxide. But these gases are not chemically bonded to each other. They're just all mixed up together in a mixture. Specification point 1.9. Understand that a pure substance has a fixed melting and boiling point, but that a mixture might boil over a range of temperatures. Okay, on the face of it, this can seem a little complicated, but it's not. Every substance, whether it is an element or a compound, has a specific boiling point. If you have a pure substance, that means that once the temperature is reached, the entire substance will melt or boil at the same time. Therefore, it has a fixed melting/boiling point. This is often represented in a graph like the one you can see on the right-hand side. The graph goes flat when a change of state is happening. So that first plateau is where the substance is melting, and the second one is where it is boiling. You will only get a graph like this for pure substances. Now to consider mixtures. When you melt a mixture, you actually melt each part of the mixture separately. Consider a chocolate chip muffin. We're going to simplify things a bit here, but I hope the analogy will help you. You have the 2 main substances in chocolate chip muffins, the chocolate chips and the cake. If you were to slowly heat up your muffin, constantly increasing the temperature, the chocolate chips would start to melt way before the cake. So let's say the chocolate chips start melting at 50 degrees C, and then eventually the cake starts to melt at 150 degrees C. When referring to the whole mixture, we would say that it melts over a range of temperatures, from 50 degrees to 150 degrees. When we represent this on a graph, as you can see in the bottom right, we don't get any plateaus for the mixture, because it doesn't melt all at once, but over a range. So that red graph there shows that there are no plateaus. So to clarify, pure substances melt and boil at specific fixed temperatures, and mixtures melt and boil over a range of temperatures. Okay, so how is this examined? Point 1.8 often requires candidates to define element, compound, or mixture for 1 or 2 marks, and/or they might need to state whether a given substance is an element, compound, or a mixture, often with the aid of a diagram, like below. So for example, they might say, which of these, A, B, C, D or E, is an element? And you would look to see which ones are made up of only one coloured atom. So that would therefore be A, because they're all blue, and C, because they're both green. Now they might ask then, which of these could be a compound? So you're looking for ones that have more than one type of atom, i.e. different coloured atoms in this case, bonded together. So then you find B, which is containing both red and blue atoms, and D, which contains purple and yellow atoms. And finally, which of these would be a mixture? Well, that just leaves E. Now you have two different types of atoms in this, the green ones and the brown-orange ones. However, the brown ones and the green ones are not chemically bonded to each other. You have green atoms and brown atoms mixed together. So E would be a mixture. For point 1.9, you could be asked to interpret a graph, identifying which line represents a mixture or an element, or a pure or impure substance. For example, in this graph you look at both lines, A and B. Whichever line has flat plateaus is the pure substance. So looking at the two lines, although A does go flatter at 2 points, you'll notice it's still diagonal. Okay? Whereas in B, you've got two clear plateaus. So B is the pure substance and A is the impure. A is the mixture and B is the element. You could also be asked to explain why the mixtures melt or boil over a range of temperatures. You would just explain that the different parts of the mixture have different melting and boiling points and therefore melt or boil at different times. Thank you for watching. Don't forget to hit the like and subscribe button if you found this video helpful, and keep an eye out for future videos.